Hello, my name is Che Cobb, and I live in Melbourne, Florida. I am married and currently have two cats also. I am a system engineer for the first responders communication system in Brevard County. I am looking forward to transitioning into a new field after graduating with a CS degree this coming up spring. I will be talking about the Caml programming language. We all know that there's a vast spectrum of programming languages used today to develop different software applications. One important programming language is Caml, which stands for Categorical Abstract Machine Language. Caml is a general-purpose programming language designed with program safety and reliability in mind. It is very expressive yet easy to learn and use. Caml supports functional, imperative, and object-oriented programming styles. It has been developed and distributed by INRIA, a French Institute of Computer Science and Applied Mathematics, since 1985. The most popular variant is OCaml, or Objective Categorical Abstract Machine Language. Caml finds its source from the ML language, meta language. In this report, I will define Caml, identify its concepts, and application in programming. What is Caml? When it first developed at INRIA, it was commonly used for educational purposes for their students. It offers a heavy programming language with efficient native code compilers for a variety of architectures. Caml is a general-purpose industrial-strength programming language that specializes in safety and expressiveness. It's mostly used as a teaching language. It is also highly preferred by large companies because of its negligible margin of error. Caml was initially used to develop applications because of its symbolic computations, compilers, and interpreters, automatic theorem provers, and program analyzers. Caml is now extensively used for teaching programming, and it's also used for making projects all over the globe. It is a safe language ruling out programming errors, which is verified by the compiler before the program is executed. Here I will introduce the concepts which will make Caml secure, unique, and versatile. First, Caml is a powerful system. It is equipped with type inference and parametric polymorphism. This allows allocating of type of operations on the collection of objects independently. Type inference further allows executing such operations without explicitly providing the data types of parameters and results. Secondly, it has a user-defined data types and pattern matching. Algebraic data types of combinations and sums can be defined. Data structure-oriented functions can then be defined using pattern matching. The third concept of the Caml language is auto memory management. It has a fast, incremental, and unobtrusive garbage collector which powers it in automatic memory management. This makes the application faster, dynamic, more optimized use of memory makes the application efficient and easy to use. The memory manager works in parallel with the application so that there's no noticeable stop of the Caml programming when the garbage collector is running. Allocation and deallocation of data structures is kept implicit. There is no new or free primitives and handled by the compiler. This way the programs are much safer since spurious memory corruptions can never occur. Another concept of Caml is it has individual compilation of standalone applications. A portable bytecode compilers allow creating standalone applications that are Caml Lite or OCaml programs. A foreign function interface allows Caml code to interoperate with C code when necessary. Interactive use of Caml is also supported via a read, evaluate, print loop. Since Caml is a sophisticated system, which makes it the fifth concept, it allows the organization of modules in hierarchy and changing the modules into parameters, setting one module over the other. This makes traversing of modules easier and finding of text in a proper format, which is easy to compile and execute. The sixth concept is Caml's imperative features. Caml contains an array of imperative features, can record components for variables, and arrays can be modified. There are varieties of loops available for controlling statements in the program. These imperative features include the usual while and for loops, as well as mutable data structures such as arrays. One such array function is the array.create function. Arrays can either be given extensions between the brackets or latticated and initialized with the array.create function, then filled later up by the assignments. The last concept is polymorphism. Caml is a polymorphic type system which some undefined types can be used as variables which can be later instantiated. Thus, for instance, a single sorting function can be applied to a list of integers, a list of integer pairs, and a list of records without requiring any code duplication. Caml has started to be used in many software applications. Since the late 1990s, OCaml has been steadily gaining popularity and attracted a significant user base. In addition to impressive programs developed in OCaml, the user community has also contributed many high-quality libraries, frameworks, and tools in the areas ranging from graphical user interfaces and database bindings to web and network programming, cross-language interoperability, and static programming analysis. Some of the softwares that have been developed using Caml is Hack, a new programming language created by Facebook, and the compiler is written in OCaml. Flow, a static analyzer for JavaScript. COQ, a formal proof management system. Oxygen web development framework, and OPA, an open source programming language for web development. In conclusion, overall, Caml programming provides one of the best solutions for safe and powerful way of expressing meta-language derivatives using object-oriented technology as its base. As an XML-based programming language, it has a lot to offer to its users, even as large organizations use Caml to provide perpetual solutions for heavy-coded compilation jobs and dynamic front-end user interfaces. Now I will show some examples of how to use the Caml programming language. The first example, I will show two functions, the square and the factorial. You use the keyword let to declare the variables. You can see let square and let recursive factorial function. The keyword val shows that it's an integer and it's part of the function. So for example, if you put in fact5, it will come back with an integer of 120. And if you put in the square of 80, it comes with an integer of 6400. Now here's an example of the automatic memory management. All allocation and deallocation operations are fully automatic. Lists are predefined in Caml. The empty list is written in brackets, and the constructor allows prepending an element to a list is written in double colon the in infix form. Let declares the L list numbers. The keyword val shows that the inside the list is all integers. So the first input, you just put in 1, 2, 3, and the int list comes back with 1, 2, 3. But if you put in 5 in the element in the list, it will come back with 5 as the first number in the list. This is polymorphism example for sorting lists. Insertion sort is defined using two recursive functions which use pattern matching. Note that the type of the list elements remain unspecified if represented by a type variable A. Thus, sort can be applied to both a list of integers and to a list of strings.